for being here. So I'm going to speak about cold spells in a changing climate. So that's a piece of work that we've done either at IPSL, so it's work that was done across IPSL, Zurich and Leipzig. So why are we focusing on cold spells? So the premises is that the energy demand, especially in Europe, in the winter is mainly tied to low temperature. So the colder the temperatures, the more energy we need to warm our houses. And the second point is tied to climate change. So we noticed that the average European temperatures have steadily increased in the past decade. So that's climate change. And if you look at the graph on the right, let's focus on the blue, the green balloons. So this is the winter temperature changes between 1950 to almost now. So it goes up and down. So there's a trend, an upward trend, which is the same for the whole winter, or if you take just the coldest month or just a period of the coldest 15 days. But let's focus on the whole winter, which are the green dots. And there is an exceptional winter which occurred in 1962-1963, which is a record-breaking cold, like a record-shattering event, because it's more than 2 sigma colder than the average. So the question that we want to ask is it possible to have this type of event, which occurred during the last century, now in the 21st century, and in the present days, or in the future? Okay, so why do we want to ask this type of questions? So let's go to the US, and let's look at the 15-day colder the 15-day colder temperatures. So okay, so take a spell of 15 days and take the coldest during the winter, and this is how it goes. So it goes up and down, and there's a warming trend of around 0.4 degrees per decade. And this curve stops in 2020. And what does happen in 2021? That's the Texas freeze. So a sudden drop of temperature, which came as a surprise, hundreds of deaths, $2 billion of damage, a lot of problems with the energy supply. So the question, is this possible in Europe in spite of an increasing temperature? So we have developed several strategies. Two of them are in gray, so that there's the boosting of climate models that Eric Fischer might discuss when he connects. We've developed an in-house methodology to simulate the worst that can be based on stochastic weather generators, which I discussed a couple of days ago. But I will discuss now what I would call uchrony. What if the atmospheric patterns of 1962 and 1963, so that's the atmospheric patterns are those that Emmanuel just discussed, occurred in the present day decades? Okay, so we are going to use a reconstruction of a temperature field with analogs of circulation, which is based on a paper, so almost 14-year-old paper that we did here at LSC. So this is the result. So the question is, how cold would it be if the atmospheric patterns came back this year? The atmospheric patterns of 62, 63. So that's 60 years ago, came back again. And this is what would happen. So on, can you see my mouse on the panel B? This is what happened in 62, 63. So it was very cold over France. It was extremely cold over Germany and Poland. And now if we take the same atmospheric pattern and look at what would happen now, then we get something like a panel C. So it's still cold, but the difference between the two panels, B and C, is on the panel D. So in practice, it's warmer, between 1 and 2 degrees warmer. So this is the effect of climate change. And we made a comparison with, Sebastian Sippel in this paper also made model boosting for this event in present day simulations, in present day conditions, and this is what appears in this paper. Okay, so to summarize, if meteorological conditions like 62-63 occurred now, it would be cold, but 1 to 2 degrees warmer than the original epitome event. So the second question we try to address with Sebastian and others, such a cold winter is still possible at present, but with a lower probability. So it's possible to compute the probabilities, but the probabilities are lower, but it's still possible. So we cannot dismiss the possibility of such very cold snaps at a horizon of 2050. And I want to emphasize that why is it cold? It's cold because there's advection of cold polar air in the simulations and in what is seen. And this is a key process to generate very cold winter. In order to have cold winter, you just need to have a cold poles and circulation that will bring cold air from the poles. And last point, this is described in details in the deliverable 5.1, which is public of XAIDA. And I'll stop here. Thank you for your attention, and can take questions.